All right, we're all set.
Okay. I think, again, if you haven't introduced yourselves yet, please go ahead and do that right in the chat box. And it looks like we have a lot more people who've come in than who have introduced. Oh, I see there's more. We would just love everybody to introduce themselves. Oh, first timers, awesome. Thank you for telling us. See some more coming in.
Great that you all found the chat box. Also, when you hit that participant list and you see all the lists of names near your name, you should be able to see a little function that allows you to raise your hand via the computer. And so that is a function that we'll likely be using later today. So sometimes when we'll say raise your hand, we'll let you know if we want you to wave it in front of the camera or if we want you to click that button. And that helps us to see who might have an idea or something to share when we prompt you. So feel free to just kind of feel around. I'm seeing some people do the thumbs up, the reaction. Thank you.
Awesome.
It's amazing how much that helps when we're all meeting over video. Very cool.
So again, if you haven't yet introduced yourself in the chat room, please go ahead and just quickly write your name, where you're from. We love to see who everyone is. And if you haven't been able to find the menu bar at the bottom of your screen, maybe raise your hand. But if you hover your mouse right at the bottom of your screen, you should be able to see a menu, open up the participants, and open up the chat room. This is not the waiting room. We have taken everyone out of the waiting room. This is it. We're going to get started in just about 1 minute. We're just giving people a chance to come on in and introduce themselves. Yes, so you did not get put in the waiting room if you came in after I already opened up. So that's why you probably were not in a waiting room. We started with a waiting room and then we just opened the meeting up.
Wow, it's so great to see so many faces. We've all been social distancing for a while now, so I just want you all to know that it's really wonderful to see you all smiling and hanging out in your homes and tuning in to hang out with us for the next few minutes here.
That's right.
Really
All right. Well,
awesome
Allison,
guest.
I think we probably have a good crowd here if we want to get started today.
Great. All right. And let's see, Rose, I'm just going to unmute you, or if you want to unmute yourself as well. Let's see.
Okay.
All
Hello,
right.
everybody.
I think we can, perfect, say advance to the next slide. I'm Allison Smith. I am dialing in from Bolton, Vermont, but I'm the 4-H Youth Learning Experiences Coordinator. And I'll pass it off to Lauren and then we'll go to Rose.
Hi, everyone. I'm Lauren Traster. I'm coming today from Hyde Park, Vermont, and I am our Teen and Leadership Program Coordinator. And I am so excited, as I said already, to see so many new names and old names here today. This is great.
And I am Rose Garitano. I'm the 4-H educator from Chittenden County, and I am thrilled to have so many of you joining us today. And I'm going to be the lead presenter. So Allison's going to start us off with the review that some of you have seen about how things go when you're Zooming and learning.
Perfect. Thanks so much, Rose. So our social code for these distance learning socials. So thank you for all those who are coming back. And if you're new, just a few helpful hints is that we're going to keep you muted unless you're talking, unless we have you raise your hand to share something. That just helps cut down on the noise, and that way we can hear our presenter. And then also, if you have questions or thoughts throughout today's social, you can always feel free to put it in the chat box. I'll be keeping my eyes on the chat box so that I can make sure to bring to Rose's attention or and answer any questions. And then we did mention the raise your hand icon, but if you click on that bottom bar, which most of you probably have by now, and it says participants, that'll open up a box and you will see your name, and near your name, there's like a little hand icon, and you can click that, and that's like virtually raising your hand. So we'll let you know when we ask a question or looking for input, and we'll let you know when the appropriate time is to click that button. And then we're just asking generally, since this is a social, we want to be kind to one another, respectful. This is really a place to learn, have some fun, get to know one another. And then if you could just try to limit distractions on your end of the video screen, that would be helpful. So if you have an iPad or an iPhone or a phone that you're dialing in from, maybe just rest it on something. That way we're not on a roller coaster ride with you. Or just try to find a quiet space. It looks like a lot of you found a quiet space to dial in from. And we'll refrain from making silly faces and things. So that way we can all keep our eyes on Rose and the PowerPoint. And other than that, we hope you have fun. And I think I'll pass it back off to Rose.
Okay, so we're going to start to get to know one another a little bit with a virtual fist bump icebreaker. And I'd like you to hold your hand up in front of the camera, so your real hand, so the camera can see it. And I'm going to read off some prompts. And when I read them, if it's true about you, I want you to bend first your thumb down, then your pointer finger, middle finger, ring finger, pinky. So you're going to curl your hand into a fist. So first,
Hey, Rose, can we unshare so we can see everybody? Is that
Sure.
okay?
Yeah. Oh, way better. I was wondering how to set that up. Okay, so hands up. If this is true of you, you're going to bend your thumb down. I am inside. I have eyebrows. I eat food. I have a heart. I live in the United States. Fist bump your camera without breaking it. Yay, virtual fist bump. All right, next round. Hands up again so your camera can see your hand. Okay. I know how to communicate. I know how to think. I can solve a problem. I know how to plan. I know how to organize. Fist bump. Nice. Okay, those are skills of scientists and engineers. All right, here's another one. I can compare things. I can demonstrate. I can show how to do something. I can draw, not very well, but I can draw. I can design something. And I can evaluate. I can kind of judge something, see decide if it's good or not good. I can evaluate something. Got a fist? Fist bump. Nice. All right. I can interpret. Hands up. I can interpret things. I can analyze things. I can consider if they're good or bad. I can make a prediction about what I think will happen when I see something. I can invent something. I once invented the tuna melt, and then I found out somebody had already invented it, but I thought I invented it. I can measure. Got a fist? Fist bump. One more. I can observe. Hands up to the screen. I can observe things. I can learn. I can research. I can find out more things. I can say what I think a problem is with something. And I can smile. I see some smiles. Fist bump. Nice. So for most of those things, if we were given a fist bump, or if you put your fingers down for them, you're basically a scientist, whether you think you're a scientist or not, because those skills, almost all of them, including smiling, I think, are things that scientists and engineers do. And in today's distance learning social, we're going to be doing some science eventually, or you're going to have a science assignment. So I'm going to go back to the share screen. And okay, let's see if this is still working. So looking first, have any of you heard of learning by doing? You can raise your hand. I think Allison and Lauren can see. If you could raise your hand for the screen, if you've heard of learning by doing. And that's how most of us have always learned things, including from when we were first born. We had an experience. It's also called the experiential learning model. Something happened, or we tried something. And then we think, well, what happened? And then we think, well, so what? And then now what? What am I going to do differently after I did something? And then we kind of go back to the beginning. We try something else. And so this, if you're a 4-H'er, you've heard of the experiential learning model because you do something, you reflect, you think a little bit about it, and then you use what you learned when you try something on another occasion. So if you have ever done something and learned something, if you've ever had an experience and learned from it, I'd love it if you would use the raise your hand icon. So go to the participant list, raise your hand icon, and Allison will call on you. And I want you to share what you learned. Well, like what happened, something that you learned, and how you used what you learned.
Cool. I'm already seeing one hand. It looks like the person who has the name Baba. So I'll unmute you, or B-A-B-A. You're unmuted. Do you want to share, Lauren?
No, not really.
Did you have an experience that you learned something that surprised you that you weren't expecting?
About what though?
Anything, anytime you learn something.
Oh, I don't know. What? Okay, like, I don't know. I can't really think of anything right
Okay.
now. Sorry.
All right, well, do
Okay.
your raise hand thing icon again if something comes to mind, okay?
Okay, thank you.
All right, perfect.
We have, Rose, we do have a few others who have raised their hand, including Ryder. Ryder, I'll unmute you right now. You're good to go.
So it actually was me, Ryder, and I were just doing some videotaping and accidentally had the camera on photo instead of video when we thought we videotaped something. So we had to do it all again and learn to check more closely next time.
All right.
Oh, no, that sounds like a great way of learning by doing.
And sometimes learning by doing means you kind of make a mistake or something doesn't go quite right, and then you have to troubleshoot. So it sounds like Laura Lee and Ryder had that opportunity. Very, very nice.
Rose, do we want to go to someone else?
Sure.
All right, let's see. Let's go to Vivian. Vivian Holiday, I'll unmute you right now.
I think this happens for almost everyone when you're really little and you try to like walk and you fall, then you kind of teach yourself like what to do and what to not do.
Yeah, experience is a good teacher. And when you're little, I don't know if you're thinking about what you're thinking, but as we get older, sometimes we do put a little more thought into it before we just jump in and try, and sometimes not. But this process, this learning by doing, is very, very common, no matter what age you are. And sometimes it's an experience that we just jump into, and sometimes it's an experience that somebody has set up for us. And then we're still processing it and learning as we go. Allison, we have anybody else that wants to share, or
We do have one last person. It looks
perfect.
like Zoe Irwin. I'll unmute you. All right, you're on, Zoe.
So I learned how boater safety, so I could get my boater's license and be able to drive the boat safely.
Nice. So you had a learning experience where it was kind of set up for you, but you had to try some things, I bet,
Yeah.
for that. So very, very nice. All right, excellent. Thank you for sharing some of those examples. So that's the natural way we learn. Sometimes we set out and we have something that we want to find out. We think something is true, and we dive in and we kind of check it out to see if we're right. So this is another kind of learning that we do, and it's sometimes called the scientific method, but doesn't always have to be in a science class. It could just be in your kitchen or in your yard. And it's similar to the learner in all of us, but in this case, we have a question. We're trying to prove something. We're trying to find something out, and we might do some research. We're probably going to set up an experiment and check it out. And then we see what kind of results we get. We make a prediction, which is sometimes called a hypothesis of what we think will happen. And then after we're done, we see if we're right or wrong. And then we don't announce to the world what we found. We have to try it a couple times to make sure that it really works. And you might find this in this challenge too, that you might get kind of lucky one time, but doing something once isn't necessarily proof that it's always true. Another way that we learn information is through the engineering method. So this is another way we learn or we create knowledge or make something new. And in this case, we've got engineers are scientists too, but they use a little different approach because they're trying to solve a problem or make something new, create something new. So I'd like you to raise your hand if for the camera, just for the camera, if you think ask a question and define a problem are the same for a scientist and an engineer. So raise your hand if you think ask a question in the scientific method is the same as define a problem. Sort of the same? Kind of the same? A few people think so. They're very, very similar approaches. It's kind of where you're going to start out when you're trying to solve a problem. Okay, let me go back to my screen share. All right, so that's the engineering process. Then if we look at all three of them side by side, experiential learning, scientific method, engineering method, I want you to use the chat box and see if you can come up with something that they have in common, anything that you see that's similar from one to the other. So we'll use the chat box for this.
Great, we have some people weighing in. So Lily says do background research is a similar one. Zoe Irwin mentioned that analyzing is something that they share. Wisteria says experience.
These are excellent.
Kylie also says analyzing. Eva says communicating what happened to other people. And Lily actually just followed also with communicate results. And Vivian also mentioned communicate results.
Nice, nice. So there's a lot of similarity in these models, and they're all they all also have in common that we try stuff and then we reflect on what has happened. We think about it, and then we use that information. If you look at the scientific method engineering model, there's those arrows going back. There's those loops, and the experiential learning model, it's a loop too. So we do something, we use what we learn when we try something again. So now I want you to tell me first before we go too much further, if you know what STEAM or STEM is, and use the raise your hand icon. So and then Allison will call on someone to tell us what STEAM or STEM stands for.
All right, we have lots of hands going up. So we'll go.
Oh, beautiful.
We'll go to Lily first.
Okay, just look off acronym.
I couldn't
You're
hear.
asking.
So STEAM or STEM, either one, what they
Yeah,
stand
you just want me to list off like the acronym. Okay. So, science, technology, engineering, arts, and mathematics.
Could you hear that okay? I heard art and mathematics at the end. And I bet you got said the other ones too, Lily.
I can type it in the chat box if you want me to.
That would be great.
Okay,
Do we want to go to some more people, Rose?
sure. We'll hear from someone else and they'll probably echo what Lily said.
All right, and we have Zoe. Zoe, I'll unmute you.
STEAM means science, technology, engineering, art, and mathematics.
All right. And I'm pretty darn sure that's what Lily said too. So excellent, excellent. And I bet that more of you had that same answer. For this challenge, you're going to use science, you're going to use technology, which are applications of scientific knowledge. It's not necessarily technology. It doesn't just mean computers and machinery. You're going to use engineering skills. You're going to use some math. You're going to have to do some measuring, for example. And there's going to be some art involved too. So all of these things blend together. And so those fist bump skills that we had in the beginning, they're also wrapped up in STEAM, in lots of different aspects that have to do with science and learning. So we've got learners, scientists, engineers, and they usually have a goal to learn something new, to find out if what they think is true, or maybe to make something new, to improve something or solve a problem. So Allison, looking at the time, do we go with this video or hold?
I think, Lauren, maybe I'll let you weigh in too, but yeah, you want to do the video?
Okay, so we're going to show a short video that is a little bit about engineering, and then we're going to come back together and we'll talk about your specific challenge for this week that has something to do with chairs, which probably isn't a surprise.
All right. Let's see. I think I just need you to
stop my share.
Yeah. Thank you. And I will screen share. All right. Is everyone seeing the? Let me just start. Thank you for bearing with me here.
The engineering design process is a lot like making tacos. Here's how. Let's say you've had a long day. Maybe you've gone to class. Maybe you just got off work. Maybe you just finished an intense workout session. It's now 7 o'clock and you're hungry, but you've got friends coming over in half an hour. So what do? You go through the engineering design process. First, you define a problem or need. In this case, the problem is you're hungry and you've got people coming over in half an hour, and they might be hungry too. Next, you do some research to figure out the design requirements and your limitations. So in this case, you'd assess things like ingredients you have at hand, money you've got to spend, how much time you have before people start showing up, how many people you have to feed, and if any of those people have dietary restrictions. Once you've got a pretty solid list of criteria and constraints, you can start brainstorming ideas for solutions. Maybe you look online at nearby food options. Then, maybe you go to the fridge and you start figuring out what you could make. You weigh your options and you determine making something at home will be cheaper and faster than ordering something online. And you decide everyone likes PB&J, but you don't have gluten-free bread.
Oh.
But you do have corn tortillas.
I guess I'll try PB&J on corn tortillas.
And you make a prototype. You test it out and take a bite. It's gross. But you want to make sure it's not just you, so you get others to test it out, like your roommates or family. Everyone agrees, it's gross. You ask questions and determine what's gross about it. In this case, your testers like the tortillas, but not so much the PB&J. So you go back to the kitchen and reassess. This is what engineers call iterating, making changes based on test and user feedback. You realize,
I've got ingredients for tacos? Dope!
so you start making some veggie tacos. You try one and think,
This is kinda dry.
you have other people try it to get their feedback. Most people agree.
It's kind of dry.
So you go back to your kitchen and start iterating again. You find that you've got the ingredients to make guacamole. You make the guac and you add it to the tacos. You test it out and you're like,
This is tasting pretty good.
but some of the other testers think,
It could use some spice.
so you evaluate their feedback, you look in your kitchen, and you realize you don't have anything spicy. That's when you call your friend Sam who's coming over. And you're like,
Hey Sam, can you bring over some hot sauce? I'm making tacos.
and Sam's like,
Sure.
also,
I love tacos.
it's now 7:30 and your friends start showing up. You tell your friends,
I made tacos if you're hungry. You can add hot sauce if you want.
and then you and your friends eat the tacos. They're like,
These are pretty good. I'm going to Instagram that.
You should share the recipe online.
so you do. You've solved your hunger problem and engineered a taco party.
All right, and I will stop sharing my screen here.
Okay.
So that was just a fun little video that helped us through a metaphor of making tacos on the engineer and design process. So I was just thinking we could have a little discussion about what you saw in the video and your thoughts. And I guess I'd like to start with one part of the video that I thought was kind of funny, but also sort of interesting is what happened when the person in the video decided to make PB&J tacos? What happened, and then what happened next? What did they do about it? If you want to raise your hand using the button to weigh in, looks like Eva. I'll unmute you, Eva. What happened?
What happened was that when the person made tacos, when the person made PB&J tacos, they tried it and they discovered that it was gross. And then to make sure that they weren't going mad or had some strange thing going on with their tongue, they shared it with other people and discovered that they were correct. It was gross.
Yeah, so they were able to get some valuable feedback as part of their problem solving. And I don't know, thank you so much, Eva. I will lower your hand. And then how many times did they have to try making dinner for their friends before they got it right, or they found something that worked? You can raise your hand.
So much. So many times.
Yeah, so many times. I also see, I see Heidi's hand up. So Heidi, I'll unmute you as well. What did you notice about this process?
That they had to do it a couple of times before everyone liked it.
Yeah, and people had different preferences, right? Depending on the solution.
Yeah.
Some people wanted it spicier. And do you remember what they called that process of asking your friends how they liked your tacos?
No, I forgot.
They only mentioned it like once or twice, but it was called iterations, so iterating. So every time that they designed, the taco, they designed the meal, then they would test it out with friends. The friends would give feedback. They'd come back they'd go back to their kitchen. They'd see what resources they had, draft up some new ideas, create a new iteration of that taco, and then send it back out to their friends to try until they achieve something successful.
And can I add a really great way to remember this? So we all think that failing is bad. fail is such a negative word, but does anyone know what fail actually means? I'll tell you. First attempt in learning. So all that you do to get to that iteration where you're going to improve, people think, oh, I failed. My taco is disgusting. No, you learn something and you take that learning and you go back, and that's the engineer process. So that's a great way to think about it, is like, you didn't fail. You actually learned something that you're going to take to go back with.
Thanks so much, Lauren. I see Kylie has her hand up. Kylie, would you like to speak up? Let me just unmute you here. For some reason, hey, Lauren, are you able to unmute Kylie? I'm having trouble.
I'm unmuted.
Okay.
So I just have a comment about the video. Like, it's good that he asked his friends to try it out, because if they didn't try it out, then he would just be stuck with a PB&J tortilla sandwich. And what if they didn't like it and just like, so it's good that they made something that they all enjoyed.
Yeah, Kylie, that's such a good point, because I was kind of thinking that too. Sometimes when I try to solve a problem, I get worried about what other people might think about my solution or my idea. And then sometimes I have this feeling like maybe I shouldn't share it with other people and I should just keep moving forward with my project. But by doing that, you're exactly right. I could end up feeding my family and friends a bunch of PB&J tacos that they think are absolutely disgusting. And then I would be really embarrassed and sad that I didn't make them happy, when I could have just asked them and said, hey, what do you think of this? So by sharing your design and sharing your process as part of a team, whether that's your friends, you know, for me, it could be my coworkers or your family, when you're going about the design process and the problem, definitely including other people and other perspectives usually helps make that solution much more effective and can guard against, you know, problems down the road. So very, very perceptive.
Thank you.
And I'm gonna weigh in. Engineers do not work alone for that very reason, because they get lots of different people looking at the same thing, but from very different, as Alison, the word perspectives. Everyone comes at things just a little bit differently. So you tend, as an engineer, you tend to always work in a team, because of that very idea of everybody looks at things differently, and someone adds, you know, a little bit of this, someone adds a little bit of that, and ultimately you get a much better solution in the end.
Great, thanks so much. Is there anyone who wants to give some final thoughts to the taco design process? Raise your hand.
How many people want tacos for dinner tonight?
That's me every night, so. All right, well, I will hand it back to Rose.
All right.
So much.
So great comments on the video there. So we're going to move now into the challenge that you have, and you're going to be a little constricted about what other engineers you can consult with, because we have to do this social distancing thing right now. But here's your challenge. These are I'm going to define the problem and identify the constraints. So your challenge is to design a chair that'll hold the most weight, or as much as possible for you. And your constraints are, you get to use one standard sheet of paper. So just a regular, not a heavyweight, just a 8.5 by 11 sheet of paper. Get out of your recycle bin, or you might have some mail coming in that's on 8.5 by 11 paper. And you may use up to 6 inches of regular clear type masking tape. So not duct tape, not Gorilla tape, not just regular tape. For those are your materials in your final product. Now you're going to want to try many trials, make a prototype. You're going to have different iterations of these chairs. So you might want to collect a bunch of paper to use. But your final chair that you're going to present is made of one sheet of paper and no more than 6 inches of regular tape. So some other things that you might want to use is that extra paper, because you're going to want to do multiple trials, I imagine. You might want extra tape. Scissors will be nice to have, but if you don't have them, you can fold paper and crease it. A ruler would be helpful, but you could also use a straight edge. You're going to need some weights, something that we can share that we all probably have around. So coins, nickels, dimes, quarters. I didn't list pennies, but you could use pennies too. Canned goods. So things that are in cans, or if you don't have canned goods, if you have a bag of something that hasn't been opened, that we can use those on our chair. Like you to have a cell phone or some way to take a picture of your chair, and Lauren or Allison will send you information, because you'll upload these into a folder for Thursday. We're going to see the results of your work. And another optional thing, if you have a little stuffed animal and you want to take a picture of an animal or something silly sitting on the chair, that might be fun too. So those are some extra supplies.
So Rose, there's a question related to this. It's called a chair challenge, but Danielle wants to know, can we make a stool?
Oh yeah, I'm going to come to that. Excellent question, Danielle. So here's some other rules and requirements, some more constraints. It's got to be freestanding on a flat surface, so your chair can't lean against the wall. And it has to have a flat surface parallel to the surface that the chair is on, but it doesn't have to have a backrest. If you find that a backrest is important for your design, it can have one, but it could be more like a stool. So something that you can set those coins on, those cans on, whatever you're going to use for weights. Another constraint, it has to be at least 2 inches above the flat surface that your chair is sitting on. So if you don't have a ruler, a quarter is about 1 inch wide. So think of setting 2 quarters standing end to end. So it's got to be 2 inches above. So you can't have your paper chair just be a flat piece of paper on the table. Okay, so it has to have some elevation, 2 inches of elevation. After you make your chair, you're going to add some weights to it and write down how much weight it held. So you'll write down the number of coins, the kinds of coins, or if you used canned goods or combination, so you have some record of how much it held, and then take pictures of your work to upload into a Google folder. And you might make several versions again, because I know when I made a chair at home, it held beautifully until I added a certain amount of weight, and then the whole thing went crashing down. So I had to do some revisiting of my chair design and troubleshooting.
So Rose, there's a comment in the chat like, how, with lots of question marks. And I just want to respond. That's the point of the design challenge. There is no right or wrong. It is a challenge, and you're going to have to use your brains just to try to be creative, to think, how can you make a chair or a stool with the parameters that Rose set to try to hold something of weight? And again, there's no right or wrong answer. This is you trying to be an engineer to work through this problem to see what you come up with. So I hope that helps answer it.
Here are some other things that you could do for next steps. You could research. That was something that we saw in the scientific method in engineering. You could observe. I encourage you to observe other things that hold up weight that maybe you don't think of as being a chair, but a lot of what we learn and create, we've observed something in nature, and we've used that idea and tweaked it. So make some observations. Don't just think chair. Think of things that can hold weight. So you'll think, you'll visualize. You might make some sketches of what you're doing. You might just jump right in and try it. So there's a lot of reasons to start out with those research and observations, but you might just say, oh, I'm just going to build something. And then if you fail, you take that first attempt and you learn, then you're on the right track. So you'll repeat. So there's a expression there. If at first you don't succeed, try again. And if you do succeed, you might want to try to beat your weight that you did the first time around.
So Rose, there's a couple more questions in the chat. Eva asked, do we need some sort of name in the photo to show who made it? Yes. So when I send you the link for the Google folder, in that folder, there are directions on how to upload a photo. And it does say, just make sure you name your photo your name so that we know whose design it is. We'll also put this PowerPoint in the Google folder. So if you need to go back and look at the materials and the design process, that will all be in the Google folder.
I can't wait to see. Another question?
Yes. Sorry, Heidi's asking, so can you make anything that holds weight using the parameters that Rose laid out for you, that you're trying to make using those parameters? So again, you'll have to probably look at the PowerPoint to remember, what did you say, Rose? 2 inches off the ground and 1 sheet of paper.
Yep.
Yeah.
Those are your constraints. And again, look at the picture here that you see on your screen is lots of chairs that mostly look like chairs. But your chair might look like something completely new. It might not look like what you're sitting on right now, but you've got those constraints. And so again, you get 1 sheet of paper, 6 inches of tape, freestanding, flat surface that's parallel to the surface your chair is on, can't lean, and 2 inches above the surface. And so you're gonna have to do some creative thinking. My chair, I ran out of coins in my house when I made it. I was shocked at how well my first chair held up weight, and I think you'll surprise yourself too. So any final questions?
There's some conversation just about the materials, but just to clarify, it's 1 piece of paper, 6 inches of regular clear tape. It looks like maybe there was a typo on one of the PowerPoints, but clarifying it here, especially in this sheet, last slide that Rose has up, but 1 standard sheet of paper. And if you do decide to make legs, that was another question, then those legs would have to be made of the paper and tape. You can't add other materials. So.
Right.
Lots of questions coming through, but at this point, I think wheels are turning and people are starting to think about how am I going to make my chair and how much weight is it going to hold? So I think that these are really good questions to start off sparking your challenge. It's fun to see everyone kind of digging in already.
All right, so raid your recycle bin before it goes out to the curb, because you're going to need that paper. I think you're going to surprise yourself. I'm thrilled that so many of you participated today. It's really wonderful to see your faces, and I can't wait to see you again and see your chairs on Thursday.
I know, please come back on Thursday. We really want to see what you guys come up with.
Yeah, we can't wait to see you all and chat out and talk about your results. So thanks for tuning in.
So you guys, you can hover your mouse, just click on end meeting to leave today's meeting, and we'll send you a link for Thursday.